Now, I suspected, or I suspect, that these problems are going to give you some difficulty. So let's go over questions 1 through 3. So I gave you this not linear transformation. I gave you a transformation. This is an exercise out of the book. And I gave this to you and I asked you to check whether or not it's linear, essentially. So does it preserve scalar multiplication? So how do we do something like this? We're always starting with this left-hand side. I mean, I want to go back to the definition. For demonstrating linearity, we're going to start with whatever transformation we have times a scalar multiple, and we're going to try to end up at this result. So I have here a transformation. So it's t of c times some arbitrary vector. And I can simplify that. So then it's cx, cy. And I'm doing that because the way this transformation affects a vector, it puts these components somewhere. So I want to have this simplified. I do what the transformation does. It puts the x here, and it puts the first component here, and it squares the second component, puts it in a cube root. And then I simplify this. I get a c cubed. I can pull a c cubed out. I have c times this cube root. But this cube root is exactly what t does on a vector. So I replace this with ct on the vector. I should have parentheses here. So good. I was able to start at the left and then use algebra and the definition of the transformation to end up at the right. Great. Property 2 does not hold, however. Let's try it. So I have t of a sum. So I'll simplify that sum. I put the first component of the vector here. I square the second component. Now, question mark, is this going to be the same? No, absolutely not. It would, in order for it to be the same, I'd have to have this equal to the thing on the right-hand side. And there's no way that's going to happen. You can play around with it. But if you multiply all this stuff out, the important thing to remember is that cube roots don't distribute over sums. You're not getting a sum out of this cube root. So that's not going to happen. So it does not preserve addition of vectors. So it is not a linear transformation. Satisfies property 1, but not property 2. All right, now pause here.